Hi, I am Gage and I'm going to be explaining chapter 10.7 in pre-calculus, which is polar coordinates. More specifically, we're going to be looking at how to convert the rectangular coordinates, which is x and y, to polar coordinates and vice versa. Polar coordinates are r, which is the radius of the degree, and then the theta is the angle. And what are polar coordinates? They are, instead of it being a rectangular graph or the hypotenuse of the triangle or straight, polar coordinates are more of a curved graph. And the equations we are going to be needing from converting polar to rectangular is x equals radius cosine of theta, and then y equals radius sine of theta. These equations are fairly similar to understand and think about, because as y and x both are represented on the unit circle, which is x being cosine and y being sine, so it comes back around. And then converting from rectangular to the polar coordinates, r is going to equal basically the Pythagorean theorem of the rectangular coordinates, which is the square root of x squared plus y squared. And then the theta will just equal the tangent, or inverse tangent of y over x. And that basically makes sense because as on a rectangular coordinate, you have the height and you have the base, and so it's opposite. And you want to find the angle over here, which is that with the x-axis. So it's opposite over adjacent, which is what you're trying to find. So for the first problem, we're going to be working with finding rectangular points and plugging them in to find the polar points. So for our first problem, we have 3 for the x, and then for the y, it's 3 times the square root of 3. And then you plug that into the Pythagorean theorem, which is this formula up here. So it's going to be r equals the square root of 3 squared plus 3 times square root of 3 squared. And once you do all the math there, it's going to be r is going to come out to 3 square root 2. So you can plug that in up here to your r value for the polar coordinate. And then to find theta, it's the inverse tangent of 3 square root 3 over 3, which is the y over the x. And since it's 3 on both sides that aren't in parentheses, you can cancel them out, leaving it to be just square root 3. And the square root 3 of inverse tangent is 60 degrees, and you just plug that into your theta, which is right here. So your final answer for this problem is going to be 3 square root 3 comma 60. So for the next problem, we're still working with going from rectangular points to polar points. So we have 4 as the x, and then 4 square root 3 as the y. And you want to plug into your Pythagorean theorem for r, which would be up here as it says, the square root of 4 squared plus 4 square root 3 squared. And then once you do all that, it all comes out to be 2 square root 7. So you can plug that in down here into your final answer, the polar points. And then to find theta, you do the inverse tangent of y over x, which is 4 square root 3 over 4. And again, you can cancel out the 4s since they're the same number and they're not in parentheses as being divided. So that's just going to be 1. So it's going to be the inverse tangent of square root 3. And that leaves theta to be 60. So you just plug that into your final answer. And that's basically how you convert from rectangular points to polar points. So I showed you how to do from rectangular to polar. Now we're going to go from polar to rectangular. So we're going to be using these equations instead of these ones now. So our first problem is going to be that the radius is 2 and then the theta is pi over 4. Make sure you are for your calculator, you're in the radian mode instead of the degree mode when you're doing the cosine and sine equations for this problem. So you're going to start it up as x equals 2, which is the radius, times cosine pi over 4. And then this will get you to your x being square root 2, and then your y will set up the exact same way but with sine, so it's going to be 2 sine pi over 4, and that's going to be y equals square root of 2. So your finished equation and product for this in polar coordinates in rectangular coordinates will be the square root of 2 comma square root of 2 for your x and your y. So our second problem from going polar to rectangular is the radius being 1 and the radian with theta, which is in radians this time, being pi over 2. So make sure your calculator is in radians mode instead of the degrees mode, since we're working with the radian. We'll still be working with these x and these y equations. So you'll first plug in your x as x equals 1 cosine pi over 2. The cosine of pi over 2 is just 0 because it doesn't move off the y-axis, so it's just 0 on the x-axis. And so 1 times 0 is 0, so you can plug the 0 into your finished product as the x. And then the y is just going to be sine sine pi over 2 times 1. And the pi over 2 for sine is just 1 up on the y-axis. So 1 times 1 is just 1. 0y will be 1. Making your finished product 0, 1 for your rectangular coordinate, which is x and y. So I thank you for watching this presentation of mine, and I hope now you have the confidence to complete these polar coordinate equations on your own. Thank you.